Hi everyone, welcome back to Sisya Class YouTube channel. So in today's session, we are going to learn about general organic chemistry. So we are going to cover all the concepts related to different types of electronic effects. We will learn about the nomenclature, the classification of compounds. Then we will also talk about the purification of compounds. Okay, so all those who are following the session, I hope you have solved the questions based on the last session we have covered. I hope you have learned about hydrogen and s block, revise that and solve some past year questions. You have to do that for each and every chapter, then only you will secure good marks. Okay, so in today's session, our main focus is organic chemistry. So please understand what type of questions are asked. Obviously, they can repeat the question, but if you understand the concept, then you can apply that part to any question that they ask. If they ask you about comparison of acidic strength, same concept you have to apply everywhere. So we will learn that. Okay, so before we start, I want to give you one information regarding Sisya class, and then we are going to begin with our session. Okay, so as you all know, all those who are following, we have a maths 1 year program for grade 3 to 10, in which you will get the entire CBSE, ICSE or your state board syllabus. You can enroll in this course and you can download our app. If you enroll in this course, you can get the help of Sisya AI also. So we have text-to-text doubt solving features, speech-to-text doubt solving feature, image-to-text doubt solving features also. All IIT, NIT teachers will be teaching you, obviously. Okay, and this course is just for rupees 999, very cheap per day. The cost will be less than 3 rupees. Okay, so please enroll in this course and it will start from 5th May. Okay, so you can scan this also, or you can directly download our app. All right, so this was one information that I want to give you. Now let's start with our session, and before we begin, let me introduce myself. So my name is Nidhi Narwal and I have been teaching you this EAPCET course for past so many different sessions. I hope you are following that. I hope you have seen all those sessions. I hope you are taking help of the content and you are practicing more and more questions. Okay, so I've done my post graduation from IIT Bhubaneswar. I have secured AIL 32 in CSIR net. I have 6+ years of experience in teaching these competitive examination, and in today's class we will talk about EAPCET part. And which topic we are going to cover today? General organic chemistry. Very interesting, very important, and you always get confused in these kinds of questions. So we will cover all such things. Okay, so what is the content we are going to cover today? Let's see. So we are going to start with the classification of organic compounds and the nomenclature. Okay, so how do we name the organic compounds? What are the rules we have to follow? We will understand that, and then we will solve questions based on it. Okay, after that we will talk about isomerism also. So we have different types of isomerism: structural isomerism, stereoisomerism. Stereoisomerism can be further subdivided into your geometrical and optical. So we are going to focus on structural first, and then we will cover the geometrical isomerism as well. Okay, after that we are going to talk about the reaction mechanism. How is the reaction proceeding? What type of intermediates are getting formed, how do we stabilize those intermediates, and if your intermediate is in an ionic state, then can you compare its stability, can you compare its acidic strength, can you compare the basic strength? Such questions we will cover. So stability of different intermediates, your carbocations, carbon ions, free radicals, we will understand. We will solve questions also on the basis of them. And finally, we will talk about the purification of organic compounds. And you don't have to worry too much here. You just have to focus on how to identify, first of all, carbon, hydrogen, nitrogen, halogens, if they are present in your organic compound. Once you have identified them, then if you have some impurities, how do we purify our organic compound? So we will cover that. Okay, so these are the 4 major topics that we will cover in today's session. And in addition to that, if we see any question and we have not covered that concept already, we will understand the concept first, then we will solve questions. So please focus on the question and how to solve it. We will cover everything. So stay tuned, keep your notebooks ready. Okay, let's start. Alright, so first of all, you should know about different types of electronic effects. Okay, so now the first question is, what do you mean by electronic effects? So you can have permanent effects also, you can have temporary effects also. First of all, permanent effects will include what we have written here, inductive effect. You can have mesomeric effect, hyperconjugation, resonance is quite similar to mesomeric, and we can have temporary effects also, for example, electromeric effects, very simple. So in permanent effects also, you have to know, first of all, what type of effect is present in my organic compound, obviously. Then you have to compare the strength also. So let's say your compound has both inductive as well as resonance effect, correct? Then which effect will predominate, which effect is stronger, you have to know that information also. So write down one order, then we will talk about the effects. Okay, so let's say you have multiple different effects present in your organic compound. How do we decide which effect is stronger? Okay, so if you have, first of all, resonance is strong, and in resonance also, if you have equivalent resonating structures, they will take precedence. Then your normal simple resonance or mesomeric effect. Okay, so this is your priority order. Please note this down, this is important. How do we decide which factor is dominating? How do we decide which factor is strong? This is the order that you have to follow. Okay, so equivalent resonating structures at the very beginning. After that, your normal resonance, in which you have non-equivalent resonating structures. Great. After resonance, you have hyperconjugation. Your sigma bond resonance, correct? And finally, inductive effect. So you may feel that inductive effect is present. Oh, that will stabilize my molecule so much. Inductive effect is the weakest effect that is known to us. But still, you should know which type of effect is present in your organic compound. Okay, so please note this order down. We are going to solve questions in which we will compare acidic strength. We will take help of this order there. Okay, so now we understand what is the priority order. Let's talk about inductive effect. Let's talk about these effects in detail first. Okay, so what happens in case of inductive effect? This is because of sigma bond polarization. What is polarization? There is some charge that is developed in your compound. Polarization, separation of charges. So are we breaking any bonds? We are not breaking any bonds. Are we forming something new? No, we are not. We are just talking about separation of charges. So you have a bond between two atoms. One of the atom is highly electronegative. So it will keep the electron density towards itself. So it will develop delta minus charge, and the other one will have delta positive charge. This kind of charge separation is inductive effect, as simple as that. For example, you have this compound. See, we have written the examples also. See them now. Okay, so this is your plus I group. It will give the electron density towards the alkyl chain. So if it is giving the electron density towards the alkyl chain, in that case, your alkyl chain will develop the delta minus charge, and it's the OH group itself will have the delta positive charge. Like that you can understand. Okay, so this is what we mean by plus I and minus effect groups. We have plenty of other examples also. These are some of them. So you must know first of all which group is plus I effect group, which group is minus I effect group. Then only you can proceed forward, obviously. Okay, so it is because of sigma bond polarization. It is transmitted through the chain and through sigma bond only. We are not concerned with pi bond. If we are talking about inductive effect, you are not concerned with pi bonds. You are only talking about sigma bonds here. You have to remember that information. Okay, so these are some of the examples that we have taken that you should know about, that you have to apply so that you can solve the question correctly. We will use them right now. Just note them down. Okay, so this is inductive effect. First of all, it is a permanent effect. It is a distance dependent effect. So if your group which is showing this kind of plus I or minus I effect, it is very far away from your positive or negative charge that you are trying to compare the stability of, then that effect decreases with distance. That does not happen when you will talk about the resonance effect. That will not happen in case of hyperconjugation also, because they are distance independent. But this effect is distance dependent effect. After 3 carbon atoms, this effect disappears. For our understanding, after 3 carbon atoms, forget about inductive effect. It will not operate, and it only operates through sigma bond. So these are some of the features that you should know about. Okay. Alright, so this is all about inductive effect. Let's write distance dependent also. Okay, this is a distance dependent effect. Okay, what else? Resonance effect. We can also call it as mesomeric effect. I told about this, right? Resonance effect is also called as mesomeric effect. Now within resonance, you can have equivalent resonating structures. They are more dominant than your normal simple resonance. Okay, we understand that. Now this is also of 2 types. Now in this case, this is also a permanent effect. This operates through pi bonds. So pi bonds, lone pair of electrons. If you see something like this, please understand we are talking about the resonance effect. We are going to see examples also. Don't worry. Okay. So resonance effect, it is because of delocalization of pi electrons. We were not delocalizing anything in inductive effect. In inductive effect, we were just talking about polarization, separation of charges. That one of the atom is highly electronegative, it will keep the shared pair of electron towards itself. It is going to pertain delta minus charge. So the other group will have delta positive charge. That is all we have talked about. We have not broken any bonds in case of inductive effect. But in case of resonance effect, we are talking about delocalization, movement of electrons. Delocalization, movement. Okay, so in this case, what type of groups will move? Lone pair of electrons, negative charge, pi bonds. Okay, for example, okay, or take a simpler one. We will talk about this kind of electron deficient group later on. Okay, let's talk about pi bonds first, simpler ones. Yes. Okay. All right. So in this case, this kind of delocalization can occur. Okay, so your pi bonds are going to move. So that will create a positive charge here, a double bond here, and a negative charge here. Okay, so this is how you can represent resonance. We are moving pi electrons. Like that, you can move negative charge also. Correct? You can have resonance between a pi bond and positive charge also. Move towards the positive charge, move away from the negative charge. Okay, so you can have these different kind of resonance in your compounds that you should know about. Okay, see, we are seeing the resonance between 2 pi bonds, a pi bond and a negative charge, a pi bond and a positive charge. Exactly like pi bond and the negative charge, you can see the resonance between pi bond and lone pair of electrons also. So there are lone pairs of electrons present here. Let's say this. So always remember, if you're talking about resonance between a pi bond and a negative charge, go away from the negative charge. We are going away from the negative charge. If you have a resonance between lone pair of electrons and a pi bond, again go away from the lone pair of electrons. If you have a resonance between pi bond and a positive charge, go towards the positive charge. This is what we are seeing here, right? So like that you can remember, and you can apply it to any organic molecule that is given to you. Okay, so what are the important points for resonance effect or mesomeric effect? First of all, there will be delocalization of pi bonds, lone pair of electrons, or negative charge. Great. It is also a permanent effect. And what type of groups we have seen? Plus R effect groups, which are going to increase the electron density on the alkyl chain. They will push the electron density away from themselves. Those groups are called as plus R effect groups. What type of groups? Those groups which push the electron density away from themselves, plus R effect groups. Those groups which are going to pull the electron density towards themselves, we call them as minus R effect groups. Okay, see? And how to remember? If you see any kind of multiple bond is present and that group will show minus R effect, it will be a electron withdrawing group. Okay, so you can also call these groups as electron donating groups, these groups as electron withdrawing groups. The groups which pull the electron density towards themselves, electron withdrawing, which push the electron density away from themselves, electron donating groups. How to remember electron donating groups? You will have some negative charge or lone pair of electrons. So electron donating groups, how to remember? They will have some kind of lone pair of electrons on them or negative charge. How to remember electron withdrawing group? They will have some kind of multiple bond present between a less electronegative and a more electronegative atom. For example, nitrogen and oxygen, carbon and nitrogen, carbon and oxygen. Do we see the multiple bonds between less electronegative and more electronegative atom? This is the way to remember it. That is how you remember. Obviously, you cannot just from the 4 groups decide whether it is plus R or minus R. We have a way to remember. We will look for multiple bonds, and I hope we remember how to represent it in the expanded form. Then only you will see the multiple bond, obviously. So you are well aware of that. You are very smart. You have seen these functional groups multiple times. You have seen reactions of them also, so you can easily remember that. Okay, so similarly in CHO also and in ketone also, you will have a multiple bond between carbon and oxygen. So that is also an electron withdrawing group, a minus R effect group. Okay, so these are some of the features of resonance effect, and we have also seen how to decide whether it is an electron withdrawing or electron donating group. And we will solve one question also today, in which they have asked you this information only, that please tell how many electron withdrawing and electron donating groups are there. Just that. They are not asking you to compare anything, just identify them. So you should know how to identify them. We will understand it once again when we will solve question, but I have told you already, so please remember that. Okay, next, another permanent electronic effect is hyperconjugation. See, how is hyperconjugation different from inductive effect? In inductive effect also we were talking about sigma bonds, that it operates through sigma bonds, correct? But in inductive effect we were not talking about breaking of sigma bonds. I told you it is just polarization, separation of charges. There is no breaking of bonds in case of inductive effect, but in hyperconjugation you can break sigma bonds, you can move sigma bonds, so that makes it different. Okay, see, hyperconjugation, see, delocalization we have written here. In inductive there was no delocalization, not of sigma bonds, not of pi bonds. Remember that. Okay, is hyperconjugation dependent on distance? No. Only inductive effect is dependent on distance. Resonance effect, hyperconjugation, it is distance independent. Okay, it will not depend upon the distance. Great. So, delocalization of sigma electrons of carbon-hydrogen bond adjacent to a double bond or a carbocation. Let me give you example. Okay, I will write it here. This is the example of resonance. See the example of hyperconjugation also. So this is your carbocation, correct? So you have to see, a question can be asked, can this show hyperconjugation? Let's find out. So this is my carbocation. Look for the alpha carbon. Is your alpha carbon sp3 hybridized? I can see it is sp3 hybridized. Is your alpha carbon present with alpha hydrogens? I can see that also. So will it show hyperconjugation? For sure. So what are the two conditions you will look for if you are trying to see whether your carbocation can show hyperconjugation? So you will look for the alpha carbon, the carbon that is next to your carbocation. Okay. So we are talking about this carbocation. This will be my alpha carbon. So this alpha carbon must be, first of all, sp3 hybridized. First condition. Second condition, it must have at least one alpha hydrogen attached to it. The hydrogens which are attached to your alpha carbon are called as alpha hydrogen. Are we talking about these two hydrogens? No, this is not your alpha carbon. This is the group under study. I've told you this part also in my previous sessions. So revisit it if you don't know the concept of alpha carbon. We have covered that already. So this is the group under study. So the carbon that is adjacent to it will be called as alpha carbon. Hydrogens which are attached to the alpha carbon are called as alpha hydrogens. Okay. So how many alpha hydrogens can you count here? 3. How many hyperconjugating structures can you draw? This original structure plus 3 more. So total 4 hyperconjugating structures are possible. And by comparing the number of hyperconjugating structures, you can decide the stability of the carbocation. We will cover that also, but this is the background behind that. Okay. So first condition, your alpha carbon must be sp3 hybridized. It must have at least one alpha hydrogen. If you follow these two conditions, you can decide whether hyperconjugation is possible or not in your carbocation. And you can compare the stability. Greater the number of alpha hydrogens, greater will be your hyperconjugating structures and greater will be the stability of your carbocation, and you are done. That is all you have to do. Okay. What about resonance? You have covered that already, but say that once again. You have a pi bond and a positive charge. So we will move towards the positive charge. See, they are moving towards the positive charge. What if you have a positive charge on this oxygen? Again, we will move towards the positive charge. See, you're doing just that. You're going towards the positive charge. So like that, you can see the resonance between a pi bond and a positive charge. We have covered 3 more cases between 2 pi bonds, between a pi bond and a negative charge, between a pi bond and a lone pair of electrons. So we have covered many more examples. I hope you understand them, and please note them down, revise, and then solve questions, because these are the things that you require in order to compare the stability of something. Some species, some intermediate is given. They will ask you compare their stability. This is what you have to use, electronic effects. Okay. See the next thing. Electronic effect, electromeric effect. Now that electromeric effect is a temporary effect. Temporary effect, that means if the species which is showing that electromeric effect, if you remove it, then this temporary effect also disappears. So this is the simplest one, not that important. What they can ask you, what are the type of groups which will show plus effect? What are the types of groups which can show minus effect? That is the only question that they can ask you. So if you see some cations, plus effect. If you see some anions, minus effect, and you are done. That is all you have to see. That is all you have to compare. That is the only kind of question that they can ask you from electromeric effect. As simple as that. Okay. So, temporary effect, there will be complete transfer of pi electrons on the attack of the reagent, and if you remove the reagent, the electromeric effect also disappears. That is why we call it as temporary effect. Will the inductive effect disappear? No. Will the mesomeric effect disappear? No. Hyperconjugation, will that disappear? No. But this is because of some external reagent. Inductive, mesomeric, hyperconjugation is because of certain group which is part of your compound. So those are permanent effects. This is your temporary effects. Not that important, but you should know the name. You should be able to classify, this is my plus E effect group, this is my minus E effect group. Okay, so this is all about different types of electronic effects and what are the special features of them. We have seen certain examples also. Let's move ahead. Reaction intermediates. So I told you they will ask you question regarding the stability of intermediates. Please see. Okay, so you have carbocations, anions, free radicals, carbenes. Okay, they will not ask you much about carbenes in your higher standard for sure, but for now carbenes are formed by alpha elimination. We have covered that, if you remember, in our haloalkanes and haloarenes chapter. We have learned about beta elimination and alpha elimination. When we talk about alpha elimination, we have seen the example of dichlorocarbene. Revisit that session if you are unaware of this fact, but we have covered that already. Okay, so this is your carbene. So please don't get confused that this one has lone pair of electrons, so this must be electron rich. No, it has that lone pair of electrons, but total number of electrons which are present on your central atom carbon is only 6. So it has incomplete octet, and if it has incomplete octet, it is electron deficient, everyone. So please don't consider your carbene to be electron rich by seeing that lone pair of electrons. That is the trick carbene is playing with you. It is still electron deficient. It has only 6 electrons. In order to be an electron rich species, it must have a lone pair of electrons along with 8 electrons. Okay, so that 8 electrons is necessary in order to complete the octet. Then only it can show that behavior to donate the lone pair of electrons. This one does not have 8 electrons. It will not donate this to anyone. It is electron deficient. Okay, apart from that, carbocations, these are also electron deficient. They also have 6 electrons. Carbanions, these are electron rich. Free radicals, these are also electron deficient. And understand one simple phenomena. You can call it a trick. It is just one concept that you should be aware of. You want to stabilize something. I've told you this before also. You want to stabilize something. Everyone wants stability. How do we stabilize any particular intermediate that is given to us? You neutralize it. Okay, how to neutralize something which is positively charged? You give it electron density. How to neutralize something which is negatively charged? You pull the electron density from that species. So that is the idea you have to follow. So you want to stabilize your carbocation. You will attach it with electron donating groups. They will add the electron density to your carbocation and will stabilize them. You want to stabilize your carbanion. You want to pull the electron density from here. You will attach it with electron withdrawing groups, and that is how you can compare stability. No need to cram. Okay, I will write it here. Stability of carbocation is directly proportional to electron donating groups. And what type of groups you will avoid? Electron withdrawing groups. So electron donating groups, plus I, plus R, plus H effect groups. What type of groups we will stay away from? Minus R, minus I effect groups. They are good for us, for carbocation at least, right? And these groups we will stay away from because they will destabilize us. And if you talk about the stability of carbanion, to the reverse. They will be stabilized by electron withdrawing groups. So minus I, minus R effect groups, they are going to stabilize your carbanion. And what type of groups are going to destabilize them? These are the types of groups we will stay away from. Okay, and hyperconjugation is used for the stability of your free radical and carbocation only. Okay, free radical, carbocation and your alkene system. Please don't use it to stabilize or destabilize your carbanion. It does not have that effect on carbanion. So where are we going to use hyperconjugation? On what type of groups hyperconjugation is valid? What are the three groups I have told you about? Carbocation, free radical, alkene system. On carbanion, you will not apply the concept of hyperconjugation. Okay, remember that. Okay, so this is how you compare their stability. That is how they will ask you the question, and we will use this concept while comparing the stability also in today's class. Okay, see you the next one. Okay, this one is done, and based on that only they have written that your 3-degree carbocation will have alkyl groups attached to it. Alkyl groups are electron donating groups, and that is why this one is more stable. And see, in case of carbanions, we are saying the reverse thing, because we want to stay away from the alkyl groups. They are electron donating groups destabilize your carbanion. So now you understand the order we have written. It is based on this concept only, not random. You cram it directly, there is no need of it if you know this part. Okay, we will see how to use it also, don't worry. Alright, see the next thing. Acidity and basicity, this is the exact same thing which they ask you in a different way. So they ask you to compare the acidic strength, they ask you to compare the basic strength. One thing that you have to keep in mind, acidic strength depends upon stability of conjugate base. I told you this thing also before. Stability of conjugate base. Conjugate base is the species which is formed when you remove a proton. Covered that already. Okay. Negatively charged species. And now you know, you are proficient now. How do we stabilize something which is negatively charged? By attaching electron withdrawing groups to it. What type of groups you will avoid? Electron donating groups. Okay, see, electron withdrawing groups are going to stabilize the conjugate base, will increase the acidic strength. What type of groups we will avoid? Why? Because they will increase the electron density on your conjugate base, will destabilize it and decrease your acidic strength, and you are done. What should we do in order to compare the basic strength? Compare the stability of conjugate acid. So, conjugate acid, positively charged species, you can increase the stability of something which is positively charged by attaching electron donating groups to it. And what type of groups you will avoid? And you are done. And one more thing, if you are comparing basic strength, you also have to see how do we understand something which is basic. It has the tendency to donate the lone pair of electrons. So if it can donate that lone pair of electrons easily, good for us, great base. But if it does not want to donate that lone pair of electrons, it has a lone pair of electrons available, it does not want to participate in donation. So in that case, we will call it a poor base. So if you have a lone pair of electrons, but it is already present in conjugation within the compound, it will not donate it to someone else. You want to buy something, you want to buy a cycle, right? So obviously you will not give that money to someone else because you want to use it for yourself, correct? So in a compound, if you have a lone pair of electrons and that lone pair of electrons is already present in conjugation within the compound, you will not donate that lone pair of electrons to someone else. So your basic strength will decrease. So if you have an isolated lone pair of electrons, a localized lone pair of electrons which is not going anywhere, that particular compound will be considered as a strong base in comparison to a compound which has the lone pair of electrons but it is delocalizing. It is present in conjugation within the compound. We will consider that to be a weak base. See, we have written that. More availability of lone pair, strong base. So if that lone pair is present in conjugation within the compound, it will make your base weaker. Remember that also. We compare the basic strength by the ability to donate the lone pair of electrons. If you can donate the lone pair of electrons easily, you are talking about a strong base. If you can't donate the lone pair of electrons easily, you are talking about a weak base. So you can compare basic strength by comparison of availability of lone pair also, and this also holds true. So two factors you have to consider. Okay. Acidic strength we have already covered. Stability of conjugate base, already we have seen that, and you can now understand conjugate base is a negatively charged species. So whatever we have considered for the stability of carb anion, you can apply that information here. So is it something different? I've written the same thing in the last slide also. So this is the exact same concept. Now they are asking you to apply it for comparison of acidic and basic strength. We are not doing something new. We are just applying the same thing. We are seeing the applications of the effect as it is. Okay. See the next one. Isomerism, you can have structural isomers, for example, chain, position, functional, tautomerism, right? And you can have metamerism also. Chain isomerism. You have two compounds which have the same molecular formula. That is the very definition of isomerism, right? Same molecular formula, different properties. So you have the same molecular formula, but the number of atoms in the carbon chain are different. So what do we call such compounds? You will call them as chain isomers. Great, we remember that. What about position isomers? You have two compounds which have the same molecular formula, same length of carbon chain also. What is different? The position of the functional group, the position of the multiple bond. If that changes, you will call it as position isomers. Same length of carbon chain, but the position of the functional group is different and molecular formula obviously must be same. Okay. Then what about functional isomerism? Same chemical formula, different functional groups are present. In one case you have aldehyde, in another case you have a ketone. So alcohol and ether. So you will have the same exact molecular formula, but the type of functional group is different. Simple. Okay. And tautomerism. First of all, we are concerned with tautomerism. We have dyad tautomerism and triad tautomerism. We are not going to talk about that in much detail. We are just going to understand a simple enol. You know, enol, tautomerism. We are going to talk about that. What is enol? You have a double bond and a OH group. Okay, so this hydrogen goes here, this double bond comes here. So this is known as enol, and this is keto form. So keto-enol tautomerism. See that once again. You want to see whether keto-enol tautomerism is present here or not. You will see the keto group, see the alpha carbon. If your alpha carbon is sp3 hybridized, first of all, and it has at least one alpha hydrogen, then you will say that yes, it can show keto-enol tautomerism. What are the two conditions you will see? First of all, whether there is some carbonyl group present. Okay, by keto I don't mean ketone only. You can have aldehyde also. That is also completely okay. It can also show keto-enol tautomerism. Keto is just a term we use for carbonyl compound. Okay, in here we use it for carbonyl compounds. All right. So you will see the carbonyl group. You will look for alpha carbon. If there is some sp3 hybridized alpha carbon present, you will see whether it has alpha hydrogens attached to it. If you see at least one, you will say yes, keto-enol tautomerism is possible. And how will you see that? There will be a movement from first to third atom. So if I call this first atom, this second atom, this third atom, this hydrogen will go from first to third atom and this double bond will move in the reverse direction. And that is how you can convert your keto form to enol form. And this is how it will look. Why do we call it enol? There is a double bond ene and OH group ol, enol. This is keto-enol tautomerism. That is how you see that. And what about metamerism? It is shown by bivalent functional groups. Bivalent functional groups, that is connected by alkyl chain on both sides. So you can have ester, you can have ether. These are some of the examples of bivalent functional groups which can show metamerism. So if the number of carbon atoms in the alkyl chain, they are different on both sides of your bivalent functional group, it will show metamerism. Okay. And stereoisomerism, two types, geometrical and optical, you already know about. Okay. So now let's talk about the next part. You are going to follow these 6 rules in order to name your organic compound. You already know about that, so see them quickly, then we will solve questions. Okay, so first of all, you will identify the longest carbon chain. That is your first priority. You will see in your entire organic compound which carbon chain has maximum number of carbon atoms. That will become your parent chain. Done. After that, you will give the chain of carbon proper numbering. Okay, so from where we should start the numbering, where your number of substituents are closer together, they must get the lowest locant numbering. You already know about that also. We have just summarized it for you so you can apply it directly. Okay, what after that? You will assign the numbering to the substituents, and finally after you have done that, you will start the naming alphabetically, alphabetical order of compounds you have to write. So you have methyl, you have ethyl, you have propyl. Numbering is 2, 3, 4. We are not concerned with that. You are already done with that. But while naming the compound, you have to write each and every group in alphabetical order. That should be your top priority. Okay. Then you will add the primary suffix, the type of bond, alkane, alkene, alkyne. So ane, ene, ine. You will write that. Then you will add secondary suffix. If you have some functional group, then you will add that after it. So you have enol, enal, like that. So first you will write the type of bond which is present, ane, ene, ine. After that you will write your main functional group. Okay. Then you will write your, this is the entire order, final name, prefix, any substituent which is present in the beginning, word root, maximum number of carbon atoms in the parent chain. Based on that you will decide the word root, and then you will write the suffix. And then you have a priority order for different functional groups also, as you all know about. We have a small table for you. Please take a screenshot, then we will quickly move to questions. Okay. Alright. So please take a screenshot of this particular table. This is how you have to remember it. This is how you have to remember the priority order of different functional groups and how to decide it, prefix or suffix. You already know this table, I know, but if you don't, please memorize it. Very, very important. See the second part also. Please take a screenshot. You have to remember this table, otherwise how will you write the name of the compounds, obviously. Okay, so this is done. Let me give you one example also. Always select the highest priority group as the main functional group. That is why we have seen the table. Your highest priority functional group should get the preference. It should be taken as suffix. What about the other functional groups which are present? They are taken as prefixes. We are not concerned with that. So let's say in your compound you have 2 functional groups. One of them is present at the top of the table at a higher priority. You will consider that functional group to be your suffix, and the other functional group will be taken as prefix. I will give you one example. This is your compound. It has alcohol also. It has carboxylic acid also. And from the table you have just now seen that your carboxylic acid is given higher priority. So your carboxylic acid functional group will be taken as your main functional group, will be taken as suffix. What about this OH group? This is also a functional group. It will be taken as prefix, because according to the priority order table, it is given lower priority than carboxylic acid. Please see, 2-hydroxy taken as prefix, suffix carboxylic acid. So that is why you have learned about that entire priority order table. It is not random. You have to remember it. Otherwise, how will you answer this question? Okay. So this is all about the content. We have covered all the important points. We have taken up so much amount of time in understanding the concepts. Now let's solve questions. You will find them easy. Okay. See the first question. Write down the IUPAC name of the following compounds. So, how will you name the compounds? You will select the parent chain and you have to select such parent chain which will have the functional group. Also, it should have the multiple bonds. Okay. So, I will start the numbering from this side. Why? Because my functional group is given priority over by multiple bond. If this group would not have been present, I would have started the numbering from this side. Okay. So I have at second position amine present and at third position some alkene, right? So my correct name must be okay. One part we understand. What else? In this case, I will start the numbering from chloro group is always taken as a prefix. Always taken as a prefix. Okay. So my correct name will be at fourth position I have a chloro group at NN dimethyl benzeneamine. So my correct answer is option D. That is how you answer it based on the rules you have learned. So now I hope you can understand why we have learned the rules, how we have to apply it. Otherwise, how will you solve questions? Okay. See the next one. The number of nucleophiles in the following list. What type of group is called as nucleophile? Which has lone pair of electrons, correct? Lone pair of electrons. Lone pair of electrons. Multiple bond. So out of all these four, these two groups are considered as nucleophiles. What is the question? How many nucleophiles are present? 2. And that is how you can answer it. Okay. I hope you are answering it also. Great, Charan. Option D is correct. Yes. Rajma, I hope you are able to understand everything. If you are new to class, this is how we proceed in class. We understand the concept, then we will solve questions. Okay. So I want everyone to answer questions now. I hope we are doing it correctly. I hope we are following that. Okay. So in this case, what will be our correct answer? It will be option B. How many number of nucleophiles are present in the following list? Only 2. Rest of them are not nucleophiles because they don't have any extra charge density that they can donate to others. Nucleophiles, electron rich, electrophiles, electron deficient. Okay. See the next thing. IUPAC name of this compound. Okay, so this is what we mean by a bivalent functional groups I was talking about. Okay, see, this is your ether. Ether is bivalent. Why do we call ether as bivalent? Because it is connected by alkyl chain on both sides. Okay, so this can show metamerism. It can. Okay, all right. So how will we name this compound? At fourth position you have a methyl group, so you have 2 chains, right? You will name them separately. On one side you have benzene, leave it, and on the other side you have this alkyl chain of 5 carbon atoms. At fourth position you have a methyl group. Name it separately, name this separately, and then connect it by oxy, and you are done. Okay, so what should be the answer, everyone? For this one, it is option C. No. See, it is fourth position methyl group, right? This is what we are trying to say, right? This is what you have written, but this is ether group, right? It is not simply your alkyl chain. So how do we name an ether? Alk oxy alkane. Write it. Alk this is general layout that you follow. Okay. So what should be the name of this compound? 4-methyl pentoxybenzene. Tell me, is it making sense? What is the common layout we have to follow if you see an ether? Alk-oxy-alkane. 4-methyl pentoxybenzene. On the other side, you have benzene. So your correct answer will be option B. Okay, not whatever you have written. You have deleted it, but still. Okay, we are just practicing. But after the class, please read about it, solve more questions. Okay, see the next one. Which of the following is an example of allylic halide? We have done this already. We have done this before also. Okay, so let's see that once again. Allylic halide, we have covered it in haloalkanes and haloarenes. If you have not seen that session, please revisit it, revise the concepts. Okay, so how do we understand allylic halide? You have a double bond. Okay, adjacent carbon atom is sp3 hybridized, and there is a halogen attached to it. Then you will call such compounds to be allylic halides. This carbon is known as allylic carbon. What kind of carbon? Allylic carbon. Carbon that is adjacent to the double bond is allylic carbon. Halogen attached to allylic carbon, we call it as allylic halide. What if halogen is attached to your double bonded carbon directly? You will call it as vinylic halide. Okay, this carbon, this one, is called as vinylic carbon. So if you have any such compound, you will call this as vinylic halide. Maybe next time they'll ask you about vinylic halide, so you should know about that also. Okay, so the carbon that is adjacent to the multiple bond, allylic carbon, halogen attached to it, allylic halide. Okay, so please see in which case this is your double bonded system. This is the carbon adjacent to it, halogen attached to it, allylic halide. This is vinylic halide. We don't have any special name for option B. Why? Because the halogen is very far away. Okay. Similarly, in this case, you don't have any multiple bonds, so there is no special scenario here also. Okay. This one is known as your allylic halide. That is how you answer. We have done that already. Please revise it. Okay. See the next question. What is the IUPAC name of the following? First of all, when you have this kind of multi-substituted benzene system, you will do the numbering in such a way that all the groups which are attached, they get lowest possible number. Okay, first of all, remember that. Okay, so I should give them lowest possible number. After I have done the numbering, I will write the name in alphabetical order. In what order? Alphabetical order always. Okay, so I have a methyl group, I have a chloro group, I have a nitro group. Correct? So how should I name it? I have at second position chloro, at first position I have methyl, and I have nitro. What comes first, M or N? In alphabetical order, M comes before N, right? So that is how you have to name it. You don't have to write it based on the number, that I will first write methyl, then I will write chloro, then I will write nitro because it is 1 to 4. No, you have to follow the alphabetical order. So C, then M, and then N. Okay, so 2 chloro, 1 methyl, 4 nitro benzene. Option C, in alphabetical order. Okay, see the next question. The decreasing order of priority orders. Please see the entire table that you have seen now. They have asked you a question directly based on the table. If you know the table, you know the answer to this. They are not asking you to write the name. Just tell them the priority order. Okay, so your correct answer here will be COH will be given maximum priority. After that, sulfonic acid, then cyanide, then aldehyde, and then alcohol. Just the order they have asked you, that is how you have to answer it. Okay, please remember the table. See, a question has already been asked. Maybe next time they will give you some other functional groups. You just have to remember the order. Done. Okay, see the next question. What is the IUPAC name of the following? See, first of all, you will select the longest carbon chain. This is my longest carbon chain. Why I have written the number 3 here? I could have done this also. I could have, but that would have been wrong. Okay, so I will remove it. Why is it wrong? I will tell you. Let me remove it completely. I have to write it in alphabetical order, right? See, in this case at third position, you are getting ethyl. And at fourth position, you are getting methyl. So we are trying to follow the alphabetical order because the rest everything is same. Okay, I'm not saying that always start the numbering from ethyl. No, in this scenario I can start the numbering from either side. My substituents are getting third and fourth position, so I was confused from where should I start. From left hand side also third fourth position substituents, from right hand side also third fourth position substituents. So I decided based on what is the substituent present. It was ethyl and methyl. Ethyl comes first in the alphabetical order, so I started the numbering from right hand side. Okay, so see the correct name: 3-ethyl 4-methyl hexane. Okay, option C, and you are done. Alright, see the next question. Possible number of isomers including stereoisomers which are possible for C4H9Br. Let's write. This is the first one, simple primary alkyl halide I have written. Okay, we can do this also. This is also a possibility, a secondary alkyl halide. I can write tertiary also. Correct? This is also a possibility. What else I can do? I can do this also. Okay, so these are the possible structural isomers I can make, but they have asked you how many possible isomers including stereoisomers. So I have to see out of all those 4 I have written, how many can show cis trans isomerism, geometrical or optical. Any one of them will be called as stereoisomerism. How to select compounds which can show optical isomerism? You will choose such a compound in which your carbon atom is attached to 4 different groups. Then it can show optical isomerism. Such a carbon which is connected with 4 different groups, what do we call it? We call it as chiral carbon. Okay, so please see which carbon is present here that is attached to 4 different groups. Can you see this carbon atom? It is connected with hydrogen, a CH3 group, a ethyl group CH2CH3 and Br. So this one is your chiral carbon. It will exist in 2 optical isomers. So these 4 you have already written. Its optical isomer you will add to it and your total number comes out to be 5. Okay, so please see optical isomerism also. If it tells you to include stereoisomers, if it is written in the question that please write structural isomers only, then your answer would have been 4. Okay, so why are we writing 5? Because we are including stereoisomers. Okay, see the next question. Which one of the following carbon ions is least stable? I have written this thing, if you remember. Negatively charged species carbon ions are stabilized by electron withdrawing groups. I hope you remember. And what type of groups you will avoid? They are going to destabilize you. That is your entire question. That is how they will ask you. So you just have to identify which group is electron donating, which group is electron withdrawing, and you can answer this question. Okay, see, this is electron withdrawing group. It can show minus R effect. It is good for us. It will stabilize your negatively charged species. This can also show. This is also electron withdrawing group. So this one is also good for us. This is electron donating group. It shows plus I effect. Plus I effect groups destabilize you. Okay, and they are asking you which one is least stable. This is not connected with any group, right? It is just CH3. Hydrogen does not show anything. Hydrogen will not show any type of electron donating effect. It will not show any type of electron withdrawing group. So hydrogen is good. it will not show any effect, it will not destabilize you, it will not stabilize you. So leave hydrogen out of the picture. So this one is your least stable compound, right? Because it is connected with a electron donating group. Alright? So this is how we can understand it. I hope you understand everything. Alright, let me see if you have asked any questions. Yes, Harshit, I can see your comments. Harshit, the practice questions are provided in the PDF. You can find it on the Telegram channel. Alright? It is shared on the Telegram channel. Please see. And we are trying to provide you zoology and botany classes. Okay? But so far we are only taking up chemistry and maths. Alright? So we will hopefully add the biology section also. Alright, Harshit, please see the PDFs. They are available on the Telegram channel. Alright? Okay. Alright then everyone, that is all for today. So we have learnt about different concepts related to organic chemistry. We have learnt about different types of intermediates, different types of electronic effects. We have seen the nomenclature also, and we have solved some questions based on them. Rest of the questions are available in the PDF. So please solve them also, cross-check your answers, practice more and more questions. And yes, you have to practice more and more questions, then only you will secure good. Okay? Secure good marks. Alright. One last thing before we end our session. Okay? So, if you have any brothers or sisters who are studying in grade 3 to 10, we have a maths course in just ₹999, very cheap. So, you can ask them to enroll in that course. You will get all IIT and NIT teachers, just like you have seen it on our YouTube channel. Your maths teacher, your chemistry teacher, we are all from IIT background. So you will get export guidance in such a cheap price. Okay, and you can take help of CCR AI also. You can scan our app from here, or you can download it, and please enroll in this course if you want to study maths from grade 3 to 10. Okay, and we will continue with our EAPCET series in the next session also. We will talk about another chapter from organic chemistry, hydrocarbons. So revise it once before the class, and if you have doubts, you can ask in the comment box. Okay, so that is all for today everyone. Have a great day, and thank you so much for joining the session. Bye everyone.